This project seems interesting. Automatic plant watering system. No microcontroller needed. This project seems interesting. The automatic plant watering system, no microcontroller. Struggling to keep your plants. This is not a well. There is a simple soil moisture. Let's see. So basically, we are creating the soil moisture sensors with a canister dish. It is not what expected. I like this technique. Let's go back and search for something more interesting. What I'm interested in looking into is some kind of project which involves computer vision. So I will only be looking the project which are related to computer vision or Python is involved in it. How to play rock paper scissors with the time of flight sensor using nano edge AI. Arduino and model using nano edge AI studio. Nano edge AI studio. What this is? Okay, so this project is also involved with something ST microelectronics and a time of flight sensor sends a matrix of distance value. You can think of it as an image but with very low resolution like 8 by 8 pixels. These sensors emit short pulses of light that last only a few nanoseconds and measure the time it takes for some of the emitted light to return. So this seems like a radar, ultrasonic, but with the light. Because it works with light pulses, it performs better in dark conditions than in bright ones. Obviously, the light sensors, then it is affected with the external light. The maximum distance that sensor can measure in the dark is around 3 meters. That's fascinating. In very bright light, the sensor may not function correctly or at all. So if the light is so bright, then there are chances that the sensor will not work at all. So logging good data with the time of flight sensor is difficult. Um, there are some conditions you have to consider if you want to log good data, be in a not too bright environment. So just make sure that you are not in a too bright, or there are no direct exposure to light. Have a background, obviously. Make sure to be in front of the time of flight. Check the log data to see if you are not too close or too far. Knowing this, we just need to plug the Nucleo board into the Arduino Uno R4. We also need to fix the time of flight to something in order to face down. Okay. To play rock paper scissors, we need to collect data representing four actions. Nothing is played: rock, paper, and scissors. So these are the four classes that they are going to train. Then they are going to log the data. For obviously, when you want to do a supervised learning, you need to collect the data. Um, so first of all, the first step is to collect your supervised learning data. So you have to provide some samples. So when the working time of flight sensor, you can choose to work with a single matrix of distances or with a sequence of matrix to capture the gestures. Obviously, when you have a time series data you need to train, then you have to do something like you take a fixed matrix, or you can create a sequence of matrix. So it will make a window. So in this case both should work, but in order to save memory usage, I chose to work with a single matrix. So there is a platform called NanoEdge AI Studio. This tool is used to create the code for collecting time of flight data. The code is attached, but here is what to do if you want to generate the same code. Open NanoEdge, go to data logger, select Arduino board, select the VL53L5CX. Then the sampling rate is 15 hertz, and the data rate and the frame resolution is 64, which means 8 by 8 and 1 frames. Click generate data logger and you will obtain a zip file containing .ino file with the code ready to be flashed onto the board. Then you need this sensors library from the SparkFun. You can include it, and um, you once you collected your data, you should open NanoEdge AI Studio, create n class classification project, and then you can perform the data collection process and you can train it. Like, let me see if I can zoom into this image. So this is something interface of the NanoEdge AI Studio. What you do is these are the classes. You add the signals for the season and lines in the file, number of values, and this is the matrix. So once done, stop the logging process. Here are the benchmarks. So the balanced accuracy is 99%, which is pretty good. The RAM being used is 0.3 KB and the flash is 82 KB. So if you are using Arduino Uno, which has the Atmega 328P microcontroller, obviously it has 32K of RAM of flash memory and 2K of RAM. So both parameters are good. Overall score is 98%, which is pretty good. The benchmark is the heart of the NanoEdge AI Studio. Here we will use all the data collect to try to find the best combination of pre-processing of the data and the best model able to distinguish the data. So if you are working on a tiny ML, you should check the Nano Edge AI. And if you already know about that, just leave a comment to let me know if you already used it. Nano Edge AI is a platform just like we discussed before, and you collect the data, and once you are done you can train the model and you can run it. This is a data logger code, and mm, id to class variables are just as simple as a simple const char pointer array and unknown nothing scissor rock and paper. So there is one more class which is unknown. Create the game. For creating a game, create a loop to play the game, create a countdown timer to let the player know when to play, wait for you to play. So basically it is just creating a game logic. Whenever you are creating any game, you need to create a game logic for it. So they are just creating that game logic. And once you have your trained model, you include nanoedge ai.h file and knowledge.h file, which is the model and the function. Add variables used by nanoedge and add an initialize function and then the detection part. So that is how the code is working. We will not go into the details of that code, but we will see that this is the code which we can check for better use cases. So this is a good project overall. It will give you an idea how to use a nano edge AI, how to use a time of flight sensor, how to create a tiny ML project. So that three combinations, it makes this project good. You create a model, you use a time of flight sensor, you use Arduino UNO, you create a model, you learn to use the Nano Edge AI Studio for ML tasks. So overall, I will give this uh, project a good score. So I think that project goes with the 8 out of 10 score from my side. What do you think? Okay, so ESP32 surveillance car, let's discuss this project as well. Basically, this is a very common project, and if you want to do any kind of surveillance where you need plain surveillance, you can use the this project. It will give you an idea to use the ESP32 cam. So you will get to know how to make a streaming from your ESP32 cam, how to create the controls just like in this picture. You can create the controls, you can create the surveillance system. Okay, so it will give you an idea how to use the making ESP32 cam for a surveillance, and also sending some outputs for control logic, like they are moving the car for forward, reverse, right, left. So it will give you some control. So keep this project as a reference. It will help you uh, in many projects. Let's watch a demo video. Here you can see they are moving the car with the ESP32 cam, and they are also controlling the car with the control buttons, forward, reverse, right, left. So this code will comes very handy. Okay, so moving back, these are the components they are using. There is a circuit diagram. They created a custom PCB, 3D model for the surveillance car. They are using L298, and this is a web interface they created. The upper one is for the video feed, live camera feed, and then they have 5 buttons, and they have a linear control for the light. So you can check this code and you can use it. So this project is very good, and you can utilize this project in many cases. Just like if I come up with a project idea where this code will also be helpful, I am thinking a baby pram monitoring project. Although there are other features, like you need to monitor um, the baby cart. If you put ESP32 cam, you may want to do some image processing on that project, where you want to know if the baby is moving, baby is sleeping, baby is weeping. You need to monitor different kind of parameters. You may also need to attach some microphone to it to notify the user or a mother that baby is awake and is crying. So you may want to add some kind of server, or you may want to add Firebase integration, so that you can send notification to the remote mobile devices, or you can implement it on a local host IP addresses in a local home area network. So these are bunch of options if you are creating a baby cart monitoring system. So it, or any other surveillance related projects, like for example just the project we have seen before, which is the water irrigation project. So if you want to do a water irrigation project, you can also add the surveillance with the ESP32 cam to it. So this is also an interesting thing to know about that. So obviously this code will comes very handy. Okay, so moving to the next project, let's see. This is a creating and solving mazes on 128 by 64 LED panel. This seems very interesting project. You can create a Pac-Man like game with it, or any other different maze solving games with it. So I think most of the recommendation of today's feed is related to the games. So yes, we have seen rock paper scissor game, and then we can see this Pac-Man like game. um, 64 by 32 LED panel. So the most popular software includes Sketch to solve a maze. In this tutorial, um, they are upgrading the process with the 84 megahertz Arduino Duo, and also provide a lot of new information. So this project is related with the Arduino Duo, and it builds a random maze from an array of 32 by 16 cell. It creates a single random point of escape, and it places over searcher, which is a red search token, at a randomly selected point in the maze. It proceeds to run the maze and eventually escape. It then shows you the unique path it found from the starting point to the point of escape. It then creates a new random maze and repeats that process. So basically, with this help, you can implement a star shortest path finding algorithm. You can implement the digester algorithm. So different kind of algorithms you can play with, and shortest path finding algorithm. So you can also extend this project with the help of the swarm intelligence. So you can also mimic with the similar interface. So if you create this interface of LEDs, and you mimic the swarm intelligence simulation with it, you can also do that. So you can create some kind of games where you can play the Star Wars like games, where or the Pac-Man like games. So there are a lot of opportunities. I will recommend the P10 LED matrices. So you can also use the P10, and you can create they are using two colors. So for example, to differentiate your um, Mars rover with the Mars walls, they are using two colors. So you may need to use the um, RGB color mat panel. So yeah, so you will also learn why this project is important. Basically, this will help you to learn um, how to create a maze, how to interface an LED matrix with Arduino, how to create a maze. This There are some complicated algorithms involved it, how to create a game. You will also learn how to create a game logic and how the games are built, and you will also learn to implement the shortest path finding algorithm, and you can also explore it with different kind of simulations. So by doing this project, it will help you a lot to improve your skills, and if you go step by step on this project, you will eventually build your skills on different algorithms. So it will improve your programming skills, and if you want to put that project in the resume, it will help you to explain your algorithmic skills as well. I will also like to discuss these points, the Arduino Duo versus the Mega. So it will help you to understand what the Arduino Duo give beneficial. Obviously, the Arduino Duo is a ARM based 32-bit microcontroller, and it has 84 megahertz clock speed. So which is nowhere near to Atmega 2560, which is an 8-bit microcontroller and have the 16 megahertz clock. So the Duo is obviously have more processing powers. At first, it thought of Duo was just a fast version of the Mega, which is not, and it has the same form factor and pinouts, just like the Mega. So it Duo operates on 3.3 volt. This is also one of the important point to keep your eye on. You should not think the Arduino Duo as a 5 volt Arduinos. So you need to add some level shifters. If you are interfacing some external peripherals to the Arduino Duo, you need to keep in mind that if that peripherals are able to communicate on a 3.3 volt pins of Arduino Duo or not. So you need to add a level shifters to them. 32-bit ARM processors on Duo is very different than the Atmega 2560. Although the pin outs are identical, but they are connected to completely different ports. In addition, direct port access is handled completely differently with different instructions and different procedures. Setting up a timed interrupt for doing refreshes is totally different as well. But on the plus side, the Duo is almost 10x faster than the Mega. So working through all these changes was clearly worth it. The Duo has more than 10x of the RAM from the Mega, that eliminate a lot of issues which has the our Mega for to handle the display. So basically this user created this project with the Arduino Mega before, and then upgraded the microcontroller with the Arduino Duo. So it has a lot of potential. Let's look to the circuit diagram. They are using a power supply, then they are using a level shifters, and then they are accessing the LED panels. So this is the author of this project. I'm bad at pronouncing names. So what else project this have? LCD display controlled by FPGA. Oh, okay. So this project is also interesting to know. Um, I had few projects on my YouTube channel which are related to the FPGA, but long ago I haven't updated that series because I rarely work on FPGAs. So but this user most have more project on FPGA. So let's see the FPGA traffic controller project. I think I will touch these projects in total different streams. So because this stream is happening on embedded systems based games, I will keep my focus on a games related projects on this stream, so that the stream have its unique characteristics and I can properly add title and description to it. So today's stream is dedicated to the gaming projects. If you are watching my videos, you may aware that I had created one short of arcade games on Arduino, where I created Arduino based stacker game, and there are also different games on 8x8 dot matrix, and so let's dedicate today's stream only for the games. Okay, so let me figure out more games related projects. So if you are new to the stream, please don't forget to like and subscribe to the channel. If you want to understand how different projects are working in a quick summary or anything, just let me know in the comment section. Let me search for the games and see if the Hackster.io will find out some games. Okay, so this is also one of the important game for the beginner. If you are new to the game development, this project is also very important, and you can learn a lot of basic game development skills. This game is pretty simple, but fun to make. It is a sequence game. So as far as I understand, this game is about, it will display you twice the sequence. It will randomly generate a sequence, and you have to reproduce that sequence within a given time frame. And if you fail to produce the sequence, or you produce a wrong sequence by pushing a buttons, there are push buttons attached to the Arduino pins, and LEDs attached to the Arduino pins. So basically, as for the peripherals, there are very limited peripherals, just 4 LEDs and 4 push buttons, and bunch of resistors, 4 resistor for current limiting to attach to the LEDs, and 4 pull-up resistors attached to the push buttons. So hardware is pretty simple, and only one buzzer is used to indicate a winning or losing state. You can create a different music if you win, otherwise losing. So all with the pulse um, to that buzzer, you can mimic a different sound for winning and losing, so that will differentiate either you win or lose. So the game begins by creating a random sample sequence, for example turning the LED one by one, and once that sequence is complete, you have to repeat that sequence in that order. It will help you to sharpen your memory, and you can increase the difficulty level if you wish. You can enhance that project as well. So this is a good project, and it will pretty simple to build and give you an idea how you can create games. So it will help you to build your game logic. So I will definitely uh, tell you, if you are interested in game development, you should give it a shot. So yes, this project could be interesting, but they did not included any details to their project. So this is a beginner level, easy to implement game as well, and they are using the joystick. So in this project, you will learn to interface the joystick, and you have Simon says would be easy to make um, if you don't have enough buttons, but I have joystick, so it use a joystick. And this is a complete logic. Let me see if I can copy and break down this code to help you understand this code with the chat gpt. And let me ask chat gpt if he can break down um, break down this code and create chunks to understand this code piece by piece. Also create a sudo code out of it. So we'll paste that code here and let me see if the ChatGPT can break down. Obviously, first of all, the global variables and pin setups. This section This section initialize the variables and assign pins. Obviously, they are using the buzzer pin, red pin, green pin, yellow pin, and blue pin. So they have red, green, yellow, and blue four LEDs, one button, and X and Y pin A4 and A5 for interfacing the joystick to it. So they are using the joystick. Then they have X position and Y position to and then they have one variable for rounds and button state and sequence. So the next thing is setup function. Inside the setup function, obviously they are creating a random seed and initializing the pins. Then they are configure the pins for the buzzer and LEDs and output, and sets the button pin as an input. Then they have a main loop. The game continuously read the button state. If the button is pressed and the game is not running, it resets and starts a new game. Please don't forget to like the stream if you are new to there, and subscribe the channel if you like to the embedded systems programming. Main loop logic. So they are reading a button, and if the button is pressed and game is not running, it reset and start a new game. The game loop, what it does, it takes a delay and create a random sequence. The game will loop while the play game is true. It will wait 1 second between rounds and generate a random color sequence for the current round, and it displays that sequence. Then reading user input. Once this displaying sequence is done, it waits for the user to input a direction based on the joystick. The read input function captures the direction from the joystick. If the input is invalid, it will keep reading until a valid direction is received. And checking the inputs versus the sequence, what it does, the game check if the user input matches the color in the sequence. If correct, it lights up the matching color. If incorrect, the game ends and all the light flashes. So in the game progress, after each round, the game checks if the player has completed 25 rounds. If yes, a victory animation is displayed with flashing lights and sounds. The game then ends. Reading input function. And okay, so the user created a button to initialize the new game. So reading input, for the joystick, they are reading two analog channels for the X pin and Y pin, and they read X pose and Y pose, which is X and Y positions from the joystick. And if the positions are um, within a certain threshold, they make assumptions of the user want to go up, down, left, right, or invalid. So these input sequence are converted to the light color and light all up. So these are the functions. What is a pseudocode? It initializes the pin, it configures the pin, it reads button state. If the game is off, button is pressed, it create a new game. And while the game is active, it waits for 1 second, it generate a new random color and add it to the sequence. It light up each color in the sequence, and then reads for user input. And if the input match the sequence and light up the color, if the input doesn't match, and the game with a failure animation. But if a user had completed the 25 rounds, it displays a victory animation. And these are the functions used in this: read input, light color, light up, and light up all. These are the function used in that game. So that's a Simon game built on the Arduino. Let's move and look for some other games. Please don't forget to like. It helps to create a boost in the reach of the stream. Obviously, the sequence game which we were discussing, it there are the similar games. LCD animation video game, it is using an LCD and a joystick. Catch the light game. Okay, so this also seems a similar game to the just like the Simon's memory game. And what this game does, okay, they have a video animation, so we'll go with that animation and see how is it playing the game.
I've named this game as Catch the Light game. In this, one player will use this joystick to catch the light which is falling from the two columns, the red column and the blue column, and the other player has to throw the light using these
Okay,
push
so
buttons
this is an important thing.
randomly
The game is
from
implemented
either of the
on
two columns.
breadboard,
And the task of
and
the player with the joystick
Arduino
is to
IDE and
catch the light
FreeRTOS header
before it
file is
reaches this
included in this
white LED
program.
which is in
So
middle.
basically,
And the
this
light in
game
this
is
white LED
created with the
can reach either
FreeRTOS.
from the red
So
column
that
or
is
from the
important
blue
thing.
column.
I had created a
So, and
series
with
on the
every press of the button, the
FreeRTOS. So
speed of
this
the light
project
falling
if
will
is
keep on
done on a
increasing.
FreeRTOS,
So
so it
let's
will be a
start
good
this game.
tutorial
And we
to
have
teach
also
for
used an active
some
buzzer
more
which
concepts
will
for the
blow once
FreeRTOS.
the light reaches this LED and the player with the joystick loses the game. Now let's start playing this game and let us see that till what time the player with the joystick sustain in this game. So I will push these buttons and will throw the light for this player. So let's start playing as I'm controlling the light by using this joystick. The motion of the joystick is catching the light, and you can see the LEDs are now glowing at a high speed since we have pressed the buttons. Okay, the player with the joystick loses, as we can see that the white LED is glowing and this buzzer has also blown. So thank you. And will throw the light for this player. So let's start playing.
Okay, so that is good. Basically, creating games will help you to boost your algorithmic skills. So it will also help you to be good at competitive programming. So I also very much recommend getting involved into some kind of game development to sharpen your algorithmic skills. It is also a fun activity to create games. Even though you are in embedded systems development, don't overlook to the game development. Game development is a very important skills to learn and master. There are many arcade games and um, embedded systems product. There are various fun lands where the embedded systems are used for the gaming purposes. So who knows, you create a good product of the games for the some playlands. So learning a game development is an important skill and always fun to do. So I highly recommend that. Okay, so there is one more similar project which is Catch the Beat on 8 by 8 matrix. So I once created the games and I very much look forward for the games which are implemented on 8 by 8 matrices. So basically why I like them, it require less hardware and more programming skills. So these kind of project fascinates me because it will help me to teach more of the development side and more of the concepts involved in the embedded development rather than just jumping onto bunch of hardwares. And uh, also I want to focus on something to build which is interesting, and not just to handle lot of hardwares, and user lost student lost the track what he was trying to do, and get confused easily. So that's why I always like the projects where we need very few external components to build it.
Hello, this is a simplified version of Osu Catch to Beat game which is played on a 8 to 8 LED matrix. The game consists in catching the falling balls. The hunter moves left and right by turning the potentiometer. You have a total 10 lives and you lose one for each missed ball. For every ball you catch, you get one life. Every fourth point won the speed
a little bit.
I'm currently. The device is simple to build and contains only a few components.
So let me see. They use 8 by 8 LED matrix, active buzzer, one potentiometer. They created an enclosure for it. There is a schematic. They directly interface the LEDs with the Arduino. I don't want to do that. I am good to use the 8 by 8 dot matrix with it. So let's move. Okay, so ping pong game implemented on OLED display is also a good game. Puzzle game for kids. Let's see what's inside that puzzle game. I think the stream goes around 55 minutes now, so I will not want the stream to go more than 1 hour, because most of my viewers watch after the end of the stream, and if the stream goes longer, uh, very few watch time occurs. Okay, so we are getting some more interesting games now, just like the basketball and the arcade games. They are fun to replicate and fun to know what we can learn from them. So yes, these are the fun projects to replicate. But we'll talk about more of these games in our upcoming streams. Let me know in the comment section if you want to continue see these kind of streams where we discuss different kind of games, and break down their algorithm to learn more how these kind of games are implemented. So we will review more of the games built with the Arduino or any other embedded systems, and just like this kind of, oh, wow, this is a good snake game. I like this, implemented on simple 16 by 2 LCD, so you don't need a fancy hardware. A snake game is also one of very important game to learn your algorithmic skills. So I think that's all for today's stream. See you in the next one. um, if you are watching after this stream is has been ended, please don't forget to comment your ideas, what you want to learn more about the game development with embedded systems. Thank you.